Hello, this is Kawasaki. I would like to talk about integration and modernization of the ad serving system in Yahoo Japan ads, getting rid of 10 years of legacy. I'm Kawasaki from Yahoo. So these are the target audiences for us today. Those who are developing and operating complex backend systems, those who are planning to revamp their systems, and those who are working as engineering managers. Those are possible targets for this presentation. First, I would like to introduce myself. My name is Sho Kawasaki. I joined Yahoo Japan in 2016, fresh from college. Ever since, I have been working as an engineer on the development and operation of the ad serving system. I have a newly born child for whom I recently took childcare leave. First of all, let me explain about Yahoo Japan ads, display ads that our team is handling. As shown in the diagram on the left, display ads receive ad requests from various ad serving spaces, including Yahoo services on PCs and smartphones. Ad requests amount to approximately several tens of millions of RPS, requiring high performance and many functions. Our team is developing and operating such a system. And we have to optimize the ads, so we have to do many things. We are developing and operating such a system that can handle a large number of ad requests. But there are issues with the ad serving system. The system uses a very old architecture, which was built 10 years ago. Before I joined the company, before the ad services were renamed from YDN or Interest Match to Yahoo Japan ads and renamed largely unchanged, while accumulating what I call technical debt during those years. So it is a very, very old system, which is unchanged largely. So this time, we will explain how we resolved such accumulated debt. That's why we have recently conducted integration and modernization of the ad serving system, including 3 specific changes. First, optimization of communication process sequence through integration of components. Second, through migration of servers from a virtual environment to the container-based CaaS environment, we reduced the cost. And third, the development language was modernized by rewriting the existing system with Go language instead of C++98. Well, we were finally able to revamp the system by reducing the dependency on the library. That was a black box and was a reason why we had to use C++98. So we selected the Go language because it is used extensively within our division for other systems, so we can utilize the library for other assets of the division, and we can receive in-house support. Let me explain the integration of multiple components more in detail. In the old ad serving system, we had 2 separate servers, the ad server to receive the requests and ad optimization server to optimize ads. After reviewing the roles of these 2 components, we decided to integrate them because it would allow us to optimize processing and facilitate future improvements. As you can see on the diagram, well, in the servers, there are 2 separate servers. The ad server communicated with server A, and the ad optimization server communicated with servers B and C. So server A and the server B and C were receiving information in series, not parallel. By integrating the ad server and the ad optimization server, we would have servers A, B, and C receive information in parallel and optimize the sequence of communication processing and control communication latency in parallel. That's why the latency will improve. I would like to talk about two specific benefits we have gained. There are two benefits as a result of the system renewal. The parallelization of communication processes has improved the average latency by 10%. And also the CaaS or CaaS environment has reduced the release time by 85%, which was leading to the reduction in the operation cost. And the Go language was originally a large-scale application, and the number of codes in the Go repository is quite large. We have achieved positive results through modernization and integration. But how did we do that? What were the innovations and ideas we had for the renewal of the system? There are three areas that we worked on. For preparation, development, and testing, I will give you the details.
First of all, preparation. In proceeding with system refresh towards 4 challenges, we did a preparation. First of all, for the system refresh, one challenge was that we had so many people involved. There was a help and effort from the BU head back then, but from the very beginning, what kind of system refresh are we going to do? We shared the vision at the very beginning, and as you can see at the title, we are going to change the architecture 10-year-old, which means that internally and externally we had to share our vision. We talked about component integration earlier, and what should component look like, and how are we going to refresh the system towards that end. We made it so that everyone was on the same page. Second, it's a large-scale system refresh, so we had so many complex functionalities. Therefore, we inventoried the functions and capabilities. So some were not used. However, they were left on the code. We identified those unnecessary functions and sorted them out. Even if we cannot delete now, but perhaps we will be able to delete until the finish of a system refresh. We checked it out with other people. And by doing this inventory, we were able to reduce the development cost. Third is the development involving a lot of people. So if we start the development with multiple people, we will be in a loss where to start from implementation. However, we did have multiple people involved from the very beginning. So as much as possible, we did the overall design and implementation of main processes so that we can work at the same time. So prepare the vacant data structure and empty functions and implemented the application flow. We call this a prototype. With this template, from a functional perspective, we were able to develop parallelly because we just added items to the structure and implementing the contents of the functions. And we also wanted to introduce clean architecture in the design. So we made it so that intent could be read from the implementation. And we also did dependency injection. And number 4 was that development team were separated because we had 2 different systems, and we didn't know each other's system very much, and there were many people who were not experienced. So we decided to hold a study meeting about each other's systems. And then we were able to confirm and check the situation of respective systems. And for the preparation, I talked about 4. So first, there are a lot of people involved in this large-scale system, so we share the goal and be on the same page is very important. Next is a lot of complex functions. Before migration, we inventory the capabilities so that we can reduce the development cost. And number 3, if multiple people are going to work on the development, initially, we should create a template of the code with a few people so that we can do the development in a parallel manner. And number 4, initially the team members were separated. However, by teaching each other about the systems, we were able to have a good understanding about respective systems. So that was about preparation. And moving on to the development. What kind of ingenuities did we use? First is sharing the knowledge. I mentioned earlier that initially a few people were involved in development, but we saw an increase in the number of developers. As we were developing the policy of implementation, we get at a loss, we face issues, but we held regular meetings so that we can create a guideline every time. The specific examples of knowledge, for instance, how to use external library and also naming conventions and restrictions on types. In using external library, we make it so that interface is being created, and also how to name the functions, and int64 is basically used, and also when implementation, if we have different choices, we create a guideline. They are very detailed, but with the guidelines, it's easier to review the code. And creating a guideline based on knowledge sharing, even if we see an increase in the number of people, in between we can share the guideline and also maintain the code quality. Number 2, development efficiency. Many functions of applications, there are multiple times typical processing. If we do parallel development, there is a risk that duplicated functions are implemented. So that we can avoid this, we have a common library and make it so that we can reuse them. One example is Go language. We have a JSON tag function. So changing from JSON to Go or back vice versa. That's when we use this. If we convert from JSON to Go structure, whether the items is necessary or not, we tend to do validation. And if we are going to convert from Go to JSON, then we want to control the items with conditions. With this, there are multiple responses going back. With this response, we want to add this, or with this response, we want to get out of this item. So we need to organize this and sort this out. So reflect was used to extend a JSON tag, and that's how we created a library. And by doing so, when writing similar processes, this process became very simple. Number 2, second example, clean architecture was adopted. So as we developed, the number of interfaces increased. So with the increase, the test mock creation takes time, so it was becoming inefficient. So by just generating necessary mock, we accelerated the speed of mock generation. So I shared with you 2 examples of efficient development, and they are small. However, common library and shorten the time of the test. That's how we worked on the development efficiency. Next, I'd like to talk about the test, how we used our ingenuities.
Various tests were conducted on the revamped system. In addition to unit testing of each function, we conducted 3 types of testing: smoke testing, functional testing, and performance testing. In a large system, data linkage and communication processing are involved, and it is difficult to cover all of the processes in one application with just a single test. In the smoke test, we used mock-ups to comprehensively check if the response and the log IF were correct. In the functional test, we confirmed that the functional requirements were met by linking actual data and connecting to the servers. In the performance test, we checked whether the system could handle a large number of requests. First, let me explain about the smoke test. In order to test whether the interface is operating as expected in a large-scale application, a mock server was used to perform the comprehensive check. The slide shows the actual system configuration. On the left, smoke test script. This is performed automatically on CI/CD. The add server for smoke is deployed from a pull request. In addition, as a substitute for the communication component for the add server during the smoke test, we have a mock server. In the add server, there are servers that communicate with gRPC by HTTP. So a mock server is prepared for each communication method. First, when the smoke test script is executed, it registers the response to the mock server from the test case configuration file. Next, the smoke test script gives an add request to the add server, which in turn proceeds with processing, while communicating with the gRPC server and HTTP server. And finally, returns a response to the add request. The access log is also output via Kafka. The smoke test script then checks whether the add response matches what was intended in the configuration file, checks whether the access log is correct by consuming Kafka, and checks whether the request matches what is expected from the mock server. If all test cases are successfully checked, the smoke test is a success. By implementing a smoke test, we can perform auto testing for overall behavior, which is difficult to cover in unit tests, and to detect on CI/CD unintended migration due to feature additions and modifications. Next is a functional test. We connect with the actual server to conduct the test. So in the functional test, we check the pattern that we couldn't check in the smoke test. Test cases are complex, and the experiment speed is slow. So those are the issues. For all of the parameters, checking all of the patterns was cumbersome as well. So functional test, we actually add the request in the test environment. So we did some manual setting. On the left is the functional test tool. This is the functional test script. So make the script, and the test was conducted semi-automatically. This section describes the content of the functional test. First, we set up the test case definition file for tools in advice. modify the ad server settings, and enter ad slots and add ads for the test. One example, what kind of creatives can be inserted in this site? And in this site, we don't insert this kind of ads. So we use the block function. This is one example. For example, for the targeting function of the ads and the images and the movies, formats are set here. Next. We execute the function test tool to be executed in the local environment and give requests, add requests to the old and the new systems. When ad server finishes processing, the test results will be provided. And after the ad server processing, the test results will be executed and output. Finally, we analyze the gap from the test results in terms of the response and access logs. The flow is similar to the smoke test, but differs in that it connects to the actual backend server for testing and confirms that the test set in the test environment is actually communicated. By using the function test, we confirmed that the data that was not covered in a smoke test was properly communicated and that there were no problems with the operation by communicating with the actual server.
Finally, performance test. Whether a large ad request could be processed and also whether performance has not degraded were confirmed. With performance test, we use CI/CD job run the script. And from the left, we have aggregate cron script. This is to collect query for the test. Perf job, it will give load to ad server, and per result viewer, it stores the result of the test. Let me explain the system diagram. First of all, the access log of production of ad server, which is the old system, is accumulated on HDFS. And within this access log, it contains query. So with CI/CD job, we need to collect them on a regular basis and store. Next, perf job will get a query, and the old and new system of ad servers will receive a request, and that will add load. And ad server with Prometheus metrics is being measured, and metrics is being drawn in Grafana. And after the load is given in perf result viewer, the result of the test and log will be recorded. Finally, the tester will confirm the result of perf result viewer and metrics of Grafana and compare the results of the test. With performance test, with the same ad request and same load, we were able to compare the performance between new and the old. So with a performance test, there were some improvements. So let me explain. One is a gRPC server. Communication latency was low, it turns out. So by using connection pool, we were able to improve. And large memory usage of function that generate structures by pprof. That was found out as well. And we improved by returning a pointer instead of a value. So these were very simple issues, but by confirming performance test, we were able to solve these issues. So with a performance test, we are now able to do a quick bottleneck checks. So I talked about 3 areas that we used our creativity in system refresh. In preparation, we reduce the development cost with functional organization and use template so that development could be done parallelly. And we also shared knowledge through study meetings. And development, we shared knowledge and we accelerated Go generate, and that led to development efficiency. In test, smoke test and performance test were conducted. And I also talked about how we realized this. So the hints that I have shared with you, I'm sure will be reference for those people who are thinking of going through system refresh or making improvements. With large-scale system refresh, sharing vision, inventorying functions, study groups, and sharing knowledge, I'm sure that these are all the hints in proceeding with projects. In a large-scale system refresh, there are members coming and going, but we have to do parallel development. So template of codes and common libraries, this will help to make the development work efficient. So for ad serving systems, in terms of requirements, there are a lot of functions and high performance requirement. So with unit test, that will not be enough. So the combination of the tests will serve you well. So let me summarize. So the consolidation of components of ad serving systems, migrating to CaaS environment, and modernization of development language were conducted. And within the presentation, I talked about preparation, development, and test. I focused on these three processes to be creative in system refresh. And through this, we were able to improve average latency by 10% and reduce release time by 85%. I hope that you will able to pick up some hints from my presentation. Thank you very much.
Kawasaki-san, thank you very much. Now we would like to have a plus talk. So the interviewer will ask questions to the presenter to deep dive the session. We would like to take questions from the audience as much as possible. If you have any question, please use the question mark button on the lower right-hand side corner of the screen. I'd like to introduce the interviewer, Tokuhiro Matsuno-san from LINE. Could you introduce yourself? Yes, hello. This is Matsuno from LINE. For the official account and other elements, I'm working on those things at LINE. Thank you. Thank you very much. Matsuno-san, so after listening to the presentation, what are your questions? Yes, from the audience, we got some questions as well. But this is similar question. What was the duration and what was the size of the team working on this project? Yes, thank you for the question. There were several different phases. In the beginning, we started with a small team for the development. About 18 months it took with a team of 4 to 5 people, but eventually the team expanded to about 10 people. I see. For the ad server, you must have people responsible. So is that the same team responsible for the ad server to begin with? Was that the team of 10 people? Well, in the beginning, there were 2 different systems. In each team, we had about 6 to 7 people. And among those people who were available, 70% of them became development resources. The rest, 30%, were doing something else. I see. So during the development period, what you originally wanted to do, and on top of that, you had to add some functions. Did you have to stop those to work on the new things, or did you work in parallel? Well, for the 18 months period, functional addition projects were less than usual, so we were fortunate in that sense. And in fact, in parallel, we had to work, but in the middle, there was a situation for about 3 months we had to suspend what we were working on. I see. So as you developed those components, Well, this time we had the target components. How about the communication with other components and the passing and receiving data from other systems? So what about the interface without external systems? You kept them unchanged? Yes, that's right. We didn't change. We just kept using the old system for the implementation. Yeah, from C++ to Go, you migrated. As you did that, how about the selection of languages? Were there any options for other than Go? No, there were not so many. Basically, within the group, we talked about the Go language, and because other people were already using Go, so it was a common asset, so we chose it. In Java, there was a good support internally for Java as well. However, for the art serving system requirements, the Java DC is a little bit slow. GC is a little bit slow. Because of the Java GC, the speed becomes slower. That's why we decided to adopt Go with less latency. So regarding Go area, were there any specific concerns about Go King? Well, for Go-related problems, well, the connection pool that I talked about earlier, well, in the Go connection pool, we didn't have the perfect knowledge about it, so we had to reset it. So that is one of the Go-related problem. And also in the case of Go, well, in the case of C++, we could communicate with the C other ways, but for Go, we thought that that would be improving. But the memory consumption was quite a lot when we look at the p-proof. So we had to deal with them with pointer. We wanted to clean it up, but the C+ handover work remained in the end. Let's see, from C++ to Go, when you changed, were you able to reduce the number of codes or lines of codes? Not so much. We have better visibility, but the actual processing we are doing is almost the same, so there isn't so much change. Well, we did the standalone tests properly, so it increased. But in terms of the application code or structure, it didn't change so much. How about the development speed? Has it improved because of the change? Compared with C++, well, overwhelmingly, Go is much easier to write. So that enhanced the speed of development. And so we migrated to CaaS environment, so the lead time to release has become shorter. So it's like we are releasing changes every day. I see. The deployment speed has become better. Is it mainly because of the migration into the CaaS environment? Yes, I would say so. Because in the past we had the IR's virtual environment of IRs. Well, we were thinking about how many releases we can do for each VIP and so forth. But because of the CaaS environment, regarding the resource, the number of bots and so forth, those were the only concern. So in that sense, it's faster. And also, pod roller, compared with the virtual environment, it is faster. I see.
From old to new, when you migrated, if there is even a small bug, I think it will impact the top line. But any ingenuities used for a safe migration? Well, in that sense, tests, variety of tests we've conducted, and the actual smoke test and performance tests. The main functions we made sure that, and we were able to check comprehensively. And when you release, like conducting A/B test and starting small, did you do something like that? Yes, indeed. the load balancer was used. So from IaaS environment to CaaS environment, so a bit of traffic will be sent, and by system we've tracked KPI and measure them. So the release itself was relatively peaceful. Well, after we started to send the flow out, there were certain things that we realized, but we only had a little traffic sent, so the impact was minimal. I see. And from old to new system, I'm sure it was a large-scale switchover, but architecture, did it change significantly so that by line you were able to compare, or were you able to radically change? Did you radically change? Well, the overall design, the clean architecture was adopted so that it could be on top of it. We did review the overall design, but the details of implementation and how much lines of code we delineate, we were following the old approach. So on lines of code, by line, similar implementation. So from C++ code, did you organize or sort them out? Right, those functions that were not used, we erased it in advance and then migrate. So 10 years. Yes, there are functions that you've created, but it turns out that no one was using it, right? Yes. So the concern, the template, you mentioned that you're providing templates, and this template is like IDE template. Is that how you offer, or is it on Wiki? How are you providing this template? So on the repository, in the repository, so there's like high-level class and high-level functions, and the template is ready to go. You can just implement them. I see. So the developer, if he wants to develop this function, and then they go to use the template and then make minor changes of the structure. So creating templates like policies. Did you have any debates within your team? Yes. Well, it was not a quarrel, but yes, we did have a discussion because I myself wanted to go through clean architecture, and this layer, the function goes into this layer, but some people would say, no, this function is not this layer, and so forth. So we discussed, and we also put it in the guidelines, and that's how we created a reference. Let's see. Study sessions. How frequent and how many times did you conduct? Well, in 6 months, maybe once a week or so. Maybe it was a bit shorter, but this was about explaining existing capabilities, right? There were 2 systems, and the system owners would explain about his or her own system. And initially, your organizational setup, people only knew about his or her own components. Well, they kind of have idea, but not in details.